Okay, these are some variations on making a T intersection, or in this case a Y intersection, or maybe a stylish T. This is one with a little bit of a lump on it, so no good version. This is one with a bit of a kink in it, which makes it, I don't know, has its point. And this is one that's this is the most neat and even one. This preserves the hexagon stacking, as you can probably see with these two. These are stacked differently. Notice that hexagons are lined up along the axis, along here, with the edge to edge along the axis, and here they're edge to edge around the circumference. No, they're not. So you see a nice long line of dots in a row, and there you see dots that are staggered. This one, the key is you make a tube of hexagons. You take one hexagon is missing. You take one out and make a hole. And see here, there's a 5 ring put in instead of a 6 ring. Well, a pentagon instead of a hexagon. Okay. Here you have a hexagon standing up. Same on both sides. And that leaves you with a way to keep stacking upwards. Notice that the line of pentagons, so the line of hexagons remains edge to edge, so you get a sort of a nicer effect of the dots. I'm trying to show that easily, but it looks better, it looks good. And then here too you get like the same stacking on the edge, whereas with which style? This one here, for example, the stacking along here is different from the stacking along here. So basically it's fairly straightforward. You just make your tube, take one hexagon out, you lever it out with a stick or something. Like that. So you have a hole in it. In that hole you put the pentagon, hexagon standing up, another hexagon standing up, and then you just keep building around. And it preserves the stacking format. So that's that one. This one I did slightly differently. It's got the same like stacking of the pentagons. I tried to do it with all hexagons, and it doesn't really work that well. You end up with a, still smooth, but you end up with a kind of a kink in it. Because one side is like this, so it's like 4 hexagons there. 1, 2, 3, 4. 2 on each side, 2 point to point. And here it's 3 hexagons. So in order to make the right number of points and valleys going around, that's what you have to do it that way. And it doesn't preserve the stacking. The stacking is that way, and it's still that way around the circumference as you go up. So it's got its applications. This is the opposite stacking. Stack all the hexagons are edge to edge. As you go around the circumference, but point to point as you go along the axis. And so to do that, you need to use a 7 ring. So there, I've done the same thing. I've taken out one piece, one hexagon, and I've just put a 7 ring on that side. This side, oh, it's coming apart now. There we go. A 7 ring on that side, onto a flat edge. In the in here, into the belly, I've pointed another hexagon. Sort of hard to make out, but that's the hexagon there. And the same on this side. The only reason I put that lump on the end is just because I was dicking around. Make arbitrary geometries. But I see this kind of thing, it's a bit like a wireframe model. You can make any shape you want out of a wireframe model, you've just got to get it right. Because all the loops go in the same direction, you can put any shape next to any shape as long as the number of magnets on each edge lines up. Here, this is the Y section. This also preserves the direction of the hexagons as you go. You can see dot, 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 like a line like that. And only the tricky part is in there. It's not that tricky, just tricky to see. So I'll put it down and it's hard to find a good angle. This one's symmetrical both sides, this side and the bottom side here, underneath this side, they're the same. And there you have it. Oops, they're all just stuck together. There's, on my Flickr page, there's plenty of other, well, lots and lots of other shapes that are more complicated, made of these kind of things. And I invite you to go and have a look.